So this first graph is really laying a foundation for us for where we're going today. Now this one is review. Hopefully when you first look at it, you immediately know what the shape of the graph is going to look like generically. Because whenever you see that squared in your equation, you know you're going to be dealing with that U-shaped graph, the parabola. And so we know we'll get a parabola. Now it's just a question about actually making the details. Well, the number inside with x, remember, moves it in the x direction. Minus moves it to the right. Okay? The minus 1 is hanging on the end. Anytime it's hanging on the end, that's up and down. Minus there goes down. And so we're going to go right 3, down 1 to get to our first point. Once we've located our first point, we now just follow the same pattern as we always do whenever it's a squared function. Now, many of you just have memorized the pattern. But I want to remind you why it works the way it does, because we're going to be creating a new pattern today, and we'll need to know why that one works the way it does. So the way that we know this pattern is when I go over 1, in order to know how far to go up, I square that 1. I square whatever I go over. Well, 1 squared, of course, is just 1. So I go over 1 and up 1. The same thing happens when we go to the left. Negative 1 squared is also a positive 1. And so that's why we go over 1, up 1 on both sides. Okay, from there, we would next go over 2. What's 2 squared? 4. So that means I need to go over 2 and up 4. Notice when I say over 2, up 4, I'm counting from that first point, the very first point that I plotted. That's what I'm counting from. All right, next up, I'm going to go over 3. And when I go over 3, how far up should I go? 9, yeah, because it's 3 squared. I'm always going back to what that function was. And since it's squared, I'm squaring whatever I go over. And so then we can complete those points and draw the curve that goes through. This is what you should have come up with. Now, I want to bring back some older information here, because I think it's time we practice it. What is the range of this function? Well, first of all, when we talk about range, is that the x's or the y's?
Y.
Yep, range is dealing with y values. Okay, what is our starting y value here? Well, it's either how high it goes or how low it goes. In this case, how low it goes. It only goes down to negative 1. And is our graph going up from there or down from there? So do you suppose that would be greater than or less than? Yeah, that'd be greater than. Now remember, the greater than symbol is the one that opens towards the left. Notice it is greater than or equal to. Every single function that we have seen so far has included the or equal to part, because it actually hits that point. By the end of the year, you will have seen some scenarios where it's not equal to, but we aren't there yet. But there will come a time when that's going to happen. Okay, another question from way back when. Is this a function?
Yes.
Yes, it is. Now, do you remember how we test to see if it's a function? Yeah, we call it the vertical line test. Remember, that's the one where we say, I can take a vertical line and draw it through the graph at any point and never hit the graph in more than one place at a time. So like an example of something that would not be a function, that wouldn't be a function. Because notice I'd hit the graph in 2 places with a vertical line. So this one is a function though. All right. Now what about domain? We haven't talked about domain in a while, really. It came up maybe a little bit on the final exam review, but that was about it. Now, if you're a little rusty on domain, maybe make a quick note of this information here. You probably got this in your notes from like way back at the start of the year, but if you want a refresher, add this. And so if I look at this graph and I'm trying to figure out the domain, a lot of people when they look at it, they start by thinking of, well, I start at this point, but that doesn't necessarily help you here, because if you start at that point and go to the left, does it ever stop going to the left? No. So it goes forever to the left. As it goes to the right, does it ever stop going to the right? No. It keeps going forever to the right as well. So it doesn't actually necessarily start at that point. It literally is going through every single x value. No matter what x you plug into this, you'll get an answer at some point. And so that's where we call it all real numbers. Now, why haven't we been talking much about domain? Because for every function type that we have seen so far this year, our lines, our absolute values, our quadratics, they've all been the same domain. They've all been all real numbers. Well, that's going to change today, because today we're adding a new function to our repertoire. Above your next graphing grid, write this equation. Y equals the square root of x. This is our parent function for the square root function family, and it's the one that we're going to be spending the rest of today with. Now, since this is a new function type, whenever we're going to do a new function type, we've always done it and started it the same way. We've made a table. Because if you're ever trying to make a graph and you don't know what it's going to look like, you'd always make a table. So that's what we're going to do for this one, but please realize, you can write this down and all that, but this is the only table you should ever have to make for a square root graph. Because once we've made the table and see what the graph looks like, you'll know the pattern, and you won't have to recalculate every time. You'll already know the pattern. You'll be able to just use that pattern. All right. So let's start our table with something easy. What if x is 0? If I plug 0 in for x up here, that means I'm doing the square root of 0. And what is the square root of 0? 1. 0, yeah. And so I know that the graph includes the point 0, 0. And so I plot that point at 0, 0. So go ahead and plot that first point on your graph. Next up. If x is 1, what's y? Well, that means I'm doing the square root of 1 up here, and the square root of 1, yes, is 1. And so I have the point 1, 1, and so we plot that point. So far, this seems very familiar, right? Every other function family we've started with up to this point has started at those 2 points, 0, 0, and 1, 1. But where it goes from there is always where things change, and that's what we're going to see happening here too. So let's see what happens next. If x is 2, what is y?
That's the square root of 2.
Yeah, well, that'd be the square root of 2. That's a decimal. In fact, it's about 1.414. It's an irrational number that goes on forever. Do you want to have to plot all these decimals?
Yes.
Well, if you do, go ahead. I don't. So I'm going to skip that one. What if x is 3? What's the square root of 3? Another decimal. Okay, so I'm going to skip that one. What about 4? What's the square root of 4? 2. Okay, so that one works. So then I skip the ones that give me decimals, and I just go straight to the one that gives me another whole number. And so I have then 4, 2. Notice then we plot that point. It's over 4 and up 2. Not over 2 up 4, but over 4 up 2 here. All right, so notice we want to skip the ones that give us decimals. So what's the next x value I should choose then? Yeah, it's going to be 9. Because I know what the square root of 9 is. The square root of 9, of course, is 3. So then I can plot the point next at 9, 3. So over 9 up 3. Well, it looks like this is probably going to be all of them that fit on our grid here, but let's go ahead and check one more and see where it would go. What's the next x value that we would need to check? 16, yeah. And it's 16 because that's the next one that I actually know the square root of, because the square root of 16 is 4. Well, that one definitely is off our graphing grid. And so that looks pretty good there. But now we got a question ahead of us. We can see already that the graph is doing this. But what's happening in the rest of it? Is it going to do like one of those? Is it going to do one of these? Is it going to do one of these? What's it going to do? So let's actually check a few to see what's going to happen there. What if x is negative 1? What's the square root of negative 1? Yeah, it'd be I. But I is an imaginary number. I don't have any imaginary numbers on my graphing grid here. They're all real numbers. So I can't plot the square root of negative 1. So that means that over here in the negatives, there's not going to be any points. Okay, what about the possibility of it going down below here? Could that happen? Well, in order for that to happen, like I'd have to get a negative number in my y value. Well, the square root of what would equal, for instance, negative 1?
Like 1.
Well, the square root of negative 1, we already saw up here that that's I. It's not negative 1. Actually, there are no square roots that give negative answers. A square root will always equal a positive number. And so there's nothing there either. And so your entire graph is actually just that. Now, this pattern that we filled out in order to get this graph, does it seem familiar at all? I hope it does. Remember when we graphed our quadratic? We went at 0, 0, and then we went to 1, 1, and then we went over 2 and up 4, and over 3 and up 9. We could have gone over 4 and up 16 too if it fit. The difference is that in this graph, notice those directions are all flipped. It's over 1 and up 1, it's over 4 up 2, over 9 up 3, over 16 up 4. That same pattern is there, but that kind of makes sense because squares and square roots undo each other. And so those patterns should be related in some way. The difference, of course, is that if we just took the exact same graph from x squared and put it on its side like this, we would have that part down below. But this does not, because square roots cannot be negative. Now, there is a way to make a graph that looks like that, but we aren't going to do that quite yet. We'll save that for later. That's going to come up later this year. All right, so now back to some of those detailed questions. What is the range of this graph? Well, again, range is dealing with which? X or Y? Yep, it's dealing with Y. Where is my starting Y value? 0. And are they getting bigger or smaller than 0? Yep, bigger. It's going up from 0. Is this a function?
Yes.
Well, remember vertical line test. I hit it there once. That's okay. Over here, I don't hit it at all. That's also okay. That still means it's eligible to be a function. Could a vertical line ever hit the graph in more than one place?
No.
Nope. So that means it's a function. And last of all, the domain. Well, domain is x, because range was y. What's my starting x value here? 0. Yes. Because my x's start here, but then my x's are going to the right. We're saying this way. Now notice to the right here is the positive direction. My x's are getting bigger as I go to the right. And so x is going to be greater than or equal to 0. And yes, it's or equal to because we actually do have a point at 0. All right, now having done that, you now can make a graph for this function. So go ahead and write down this equation above your next graphing grid and make the graph. All right, so let's go and see how this one's gone. So notice we got an x minus 3. Well, before, if I had a number in with x, it would move it in the x direction. The same is going to be true here. Before, when it was a minus, that would tell me to move it to the right. The same is true here. A number hanging on the end. Well, that is always the one that moves it up or down. And a minus, before moved it down. A minus here will still move it down. All of the transformation rules are exactly the same. So all we've actually done is give you a new shape, a new pattern. But all of the old rules that you already know are going to apply here, as you'll see. So, to make our graph, first point is right 3 and down 1. From there, you now are graphing your parent function from there. It's the exact same pattern as what we did on the last graph. It's just starting at this point instead of starting at 0. So my first point goes over 1 and up 1, because the square root of 1 is 1. Next up, we go over 4 and up 2, because the square root of 4 is 2. Remember, we don't want to go over 2 because the square root of 2 is a decimal. Next up, I'd go over 9 and up 3, which is somewhere out here. It's off our graphing grid. So we can go ahead and draw our graph in. Now, when you draw your graph in, though, I do not want to see that. But I see it a lot. Because a lot of people will say, well, I reached the last point, so I must be done. But the graph actually does extend out to this point that's often some space out there and beyond even that. So you kind of mentally put that point in your head and are like, okay, I'm targeting that. How would I be moving if I were going to hit it? And that way you can kind of make that graph look a little bit neater headed out to that point. And you extend it out to the edge of the grid. So, there's our graph. Now, what's the range, the domain, and is it a function? Well, range, is that x or y?
Y.
It is y. What is our starting y value? -1. And are my y values getting bigger or smaller than that? Bigger. That means greater than. If you have trouble keeping straight which one's the greater than symbol, which one's the less than symbol, write it out, make note to yourself, and keep doing that until you got it totally memorized. Next up, domain. Well, if range is dealing with y, then domain must be dealing with x. What's our starting x value here? 3. Yep. And are my x's getting bigger or smaller from there? Well, it's going to the right, which is the positive direction, so yes, bigger. So it is greater than or equal to 3. And is this a function?
Yeah.
It passes the vertical line test, so yes, it's a function. Next graph. Go ahead and write down this equation above your next graphing grid, and then we're going to walk through this one together, just because I want to make sure it doesn't trip you up. This one is y equals 2 times the square root of x. We're multiplying by 2. We aren't adding 2 or subtracting 2. In fact, we're not adding or subtracting anything, which means that our first point hasn't moved at all. Our first point is still going to be at 0, 0. So go ahead and plot that point at 0, 0. From there, though, things are going to change a little bit. Now, to help illustrate how it's changing, and just add a little bit of visual layer to this, I'm going to start by just drawing in the points that I would plot for just the square root of x. I'm going to do those in red here, what that would look like. So that would be over 1 and up 1, and then it would be over 4 and up 2, and over 9 and up 3. I know this because I've now done that pattern a number of times. What we're going to see here is that the 2 is a vertical stretch. Now notice the words there specifically. It's the same words we used before. It's going to have the same effect as it had before, but it's one of the tougher things that we do have to deal with. A vertical stretch means it changes how far we go up. It does not change how far we go over. So instead of going over 1 and up 1 here, I'm going to go up twice as far. So I'm actually going to go up 2. So we go over 1 and up 2. Next up, instead of over 4 and up 2, I have to go up twice as far again. So instead of up 2, I'm going to go up 4. I'm doubling the height that I would normally make. So notice, knowing that original pattern is essential for this. Next up, over 9, it's normally up 3. In this case, it's going to be up 3 times 2. Always times 2, whatever we go up. And so that means we're going to go over 9 and up 6. And that's how we find each of those points with the vertical stretch in there. And then, of course, draw your curve that goes through it. All right, and again, let's go through those questions. Range. Is range x or is range y?
Y.
Yep, range is y. My starting y value here is 0, and we're going up. So your range, y is greater than or equal to 0. The domain. Well, domain's got to be your x's. Our x's start at 0, and it's still getting bigger from there, so x is greater than or equal to 0. And is this one a function?
Yeah.
Yeah. And in fact, let's make our lives a little bit easier here. We can now see that every square root function is a function. All right, so our next graph here, we have a negative out front of the square root. Before, because we've graphed negative functions before, when we graphed the negative absolute value, that made it open downward. When we graphed a negative quadratic, that made it open downward. It reflected them across the x-axis, in other words, which we can also say is flipping it upside down. It's going to do the same thing here. Basically, it means instead of going up, you're going down. So I still start at 0, 0. But instead of over 1, up 1, it's over 1, down 1. Instead of over 4, up 2, it's over 4, down 2. And instead of over 9, up 3, it's over 9, down 3. And that's it. That's our graph. Still a function. All right. Now, the question is down the right side. What is the domain? Is domain x or is domain y? Domain is x. Now, notice I asked it in a different order this time. Don't let that throw you off. Okay, so domain is x. So our x's here start at 0, and they're going up from there. And then the range is still dealing with y, of course. And our y values start at 0, but notice in this case, we start at 0, and then this graph goes down. Since it's going down from 0, our range is that y is less than or equal to 0. This is the last one we're going to do together. So please go ahead and write down this equation above your next graphing grid, and then go ahead and graph it on your own first. All right, so when doing this graph, the first thing I want to draw your attention to is notice what's happening in the equation up here. A couple of you will have looked at this and thought that it was the same as saying this. But that's different. This represents up here, that would be subtracting 3. But that's not what this means. What we're actually looking at here is negative 3 times the square root. And so since it's multiplying, this is one of those vertical stretches, and also the negative is applying the reflection here. All right, so to make the graph, we're still going to start at 0, because this one's not had anything added or subtracted to it. But instead of going over 1 and up 1, we're going to go over 1 and down 3. So your first point's over 1, down 3. Next up, we'd normally go over 4, up 2. You need to know that pattern really well. It keeps coming back, you'll notice. Well, normally I go up 2 here. 2 times negative 3 is negative 6. So that tells me I'm actually going to go over 4 and down 6. So notice, the negative is flipping it, and the 3 is stretching it. Okay, normally I would next go over 9 and up 3. Well, the normal up 3 times the negative 3 is a negative 9. So I'm going to go over 9 and down 9. And so it flips it upside down and stretches it. So the last few questions. What's the domain? Well, domain is our possible x's. Our starting value for our domain here is 0. Are my x's getting bigger or smaller? They're starting at 0 and then going to the right. That is the positive direction, so yes, it will be bigger. So x is greater than or equal to 0. The range, of course, range is dealing with y. In this case, we can see that the y values start at 0. Are my y values getting bigger or smaller than 0?
Smaller.
It's going down from there, so yes, small. That means less than. So your range will be y is less than or equal to 0.